Okay, so this is a moment generating function problem. We have a moment generating function of a random variable w, and we suppose that it's equal to this. The question is find the probability that w is greater than 1.5. So let's write this moment generating function as we have 1 over 1 minus t over 2. So that's t2 over 2 minus t. And the second part, we have 1/3 plus 2/3 e to the t to the fourth power. Now, the way that we're going to do this is that we see that this right here is the MGF, the moment generating function, of a random variable that is exponentially distributed with parameter 2. Because in the general case, the exponential distribution, the moment generating function goes like this, lambda over lambda minus t. And so I recognize this as the moment generating function for a random of a exponential random variable. Now the second part, I recognize the second part as the moment generating function of a second random variable y, which is binomially distributed with parameters 4 and 2/3. Because the moment generating function for that case, if it's n and p, the pattern goes it's 1 minus p plus p times e to the t to the nth power. And so if I replace p by 2/3 and n by 4, I get this part. So the moment generating function is the product of two other moment generating functions of two other things. And so that means that the original function w can be written as the sum of x plus y, where x and y are independent. And so this complicated moment generating function can be broken down. Lets me identify that the original random variable can be thought of as the sum of two different random variables. So let's figure out the probability that the sum x plus y is greater than 1.5. Well, there's a few ways this can happen. Well, remember that the random variable y is binomial. So there's a few possibilities. You could have that the random variable y is equal to 0, and then x could be greater than 1.5. That's one way it could work. Another way this could work is if the binomial random variable is equal to 1, and then x then would have to be bigger than 0.5. Or it could be that the random variable y is greater than or equal to 2, and then x could be anything and it still works. So if any of these three things happens, and these are disjoint events, y equals 0, y equals 1, y greater than or equal to 2, if any of these three disjoint events happens, then the sum of x plus y must be greater than 1.5. Now I break this up. X is continuous random variable, but y is discrete. So y can be equal to 0 or 1 or some integer greater than or equal to 0. Okay, so now we have independent events here. So the chance that y is equal to 0 will be 4 choose 0, 2/3 to the 0, 1/3 to the fourth power. That's the chance that y equals 0. The chance that x is greater than or equal to 1.5, that's the integral from 1.5 to infinity of 2e to the minus 2x dx. Then we have the possibility that y is equal to 1. So that would be 4 choose 1, 2/3 to the first, 1/3 to the third power, times the integral that x is bigger than 0.5. So 0.5 to infinity, 2 times e to the minus 2x dx. Then the last possibility is that y is greater than or equal to 2. So that'd be 4 choose 2, 2/3 to the second, times 1/3 to the second. That's one possibility. Second possibility would be 4 choose 3, 2/3 to the third, 1/3 to the first. Last possibility is 4 choose 4, 2/3 to the fourth, 1/3 to the 0. So those are the possibilities corresponding to y equals 0. That's the first part. Y equals 1. That's the second part. Y greater than or equal to 2 would be the sum of these three terms. Okay, so now it's just a matter of simplification. So this is 1 over 81. Then this integral is negative e to the minus 2x evaluated from infinity to 1.5. This part here is 4 times 2/3 times 1/27. Integral will be negative e to the minus 2x evaluated from infinity to this time to 0.5. And then lastly, we have these last three terms from the binomial distribution. So 6 times, that's 4/9, and 1/3 cubed is 1/9. 4 choose 3 is 4, times 8/27 times 1/3. And last is 16 over 81 for the last term. Okay, so then it's just a matter of putting these pieces together. So this right here is e to the minus 3 over 81. This part here is going to be 8 over 81 times e to the minus 1. And the last few parts here, we've got 24 over 81. Plus, this was 32 over 81. Last is 16 over 81, which works out to be 72 plus 8 times e to the minus 1 plus 8 to the minus 3 all over 81. Then we'll just plug in the calculator and get the answer out.